Today we are going to start a topic focus. Listen, this focus is very important. That is why I'm taking this topic separately. So focus already I have discussed. Now we will learn in depth regarding the focus. Clear?
Yes, sir.
So first, in case of concave mirror, what is the meaning of focus? We will learn. So write down under concave mirror. First write down, okay. Rays of light coming parallel to principal axis of a concave mirror after reflection meet at a common point on the principal axis. This point is called focus. Important note, rays should be paraxial. Paraxial means very close to the principal axis. So I will explain this topic. What is the meaning of this? Understood? Have you written?
Yes, sir.
For example, this is the concave mirror. Clear? And this is the concave mirror. This surface is polished. And this is the line, straight line I have drawn here. This is pole. Center of curvature will be here. This is radius of curvature. So meaning of what? For example, our object. If the object is at infinity, clear? Then light rays will be coming like this, parallel.
Yes, sir.
If object is at infinity, light ray is coming parallel. And these light rays are parallel to principal axis. This is principal axis. So see this light ray, this light ray, this light ray. At least how many rays are required to form an image?
Two rays.
Two rays.
Two rays.
So I just draw only two rays. There will be many rays. Clear? But I just draw to make you understand what is the meaning of this term. There will be n number of rays. Clear? But at least two rays I have drawn here. So now what is required? Normal. So I will draw a normal from the center of curvature. This is the normal. This is normal. Clear? Yesterday I have explained. If you draw
Yes,
any
sir.
line from center of curvature to a mirror, it always be perpendicular. Clear? So this is normal. This is normal. And this angle is theta. Then after reflection, it is going like this. Similarly here, this is normal. After reflection, it will go like this. Clear? This point is known as focus, F. So rays of light coming parallel to a principal axis of a concave mirror after reflection. After reflection, meet at a common point on the principal axis. That common point is known as focus. Clear?
Yes, sir.
Now, second note I have written, rays should be paraxial. Clear? I will explain this. Why is it paraxial? What is marginal? I will explain later. Meanwhile, just understood up to this point. Any doubt?
No, sir.
Now, similarly, we can write for in case of concave mirror. This is concave mirror. Now for convex mirror, I'm drawing for convex mirror. See, this is the convex mirror. Clear? And this is the our principal axis. Clear? So I have drawn a rays like this. These two incident ray are coming parallel from infinity. Our object is at infinity. Clear? Now where is the center of curvature? Here. Now I need to draw one normal. How will I draw the normal? Like this. This is normal. Similarly, I will draw the normal here. This normal must pass through center of curvature. If you have any sphere, if you draw a normal on a surface, then it will always pass through the center of curvature. Clear? This is normal. Similar I have drawn here. This is normal. This will passes through center of curvature. Now these two rays, after reflection, it will go like this. Similarly here, when you move it back, when these two rays move it back, it will meet at a certain common point. This common point is known as focus of convex mirror. Clear? Now tell me, this is real
Yes, sir.
focus, imaginary focus?
Imaginary.
Very good. So in case of convex mirror, focus is imaginary, while in case of concave mirror, focus is real. So you can write convex mirror is also known as diverging mirror. Clear? Or concave mirror is also known as converging. Clear?
Yes,
Because
sir.
after reflection, rays are converge. Can you see? These two rays after reflection, I'm showing here. See, these two rays after reflection converge. Clear? And these two rays after reflection diverge. Clear? So this lens
Yes,
is known as diverging mirror, not lens. It is mirror. Diverging mirror. This is known as converging mirror because it always converges the reflected rays, while convex mirror always diverges the reflected rays. Clear? So you can write in bracket, concave mirror is also known as converging mirror. Clear? Now write down what is a convex mirror. In bracket, write down diverging mirror. You can write rays of light coming parallel to principal axis of a convex mirror after reflection diverges. The divergent rays on being produced backwards meet at a common point on the principal axis, and this common point is known as focus of focus. Here,
Yes, sir.
in case you can write, in case of convex mirror, focus is imaginary. In real, it is not. Okay. So real focus only found in concave
Concave.
mirror. Any doubt up to this point?
No, sir.
Now I will explain why. What is the meaning of this paraxial, marginal? Clear? Why rays should be paraxial? Why is it marginal? So I will explain this. Now understand this topic is very important. Please see here. See this. For example, I am having this is concave mirror, and if I draw a principal axis like this, so many rays. Clear? Some rays I have drawn. Listen, this is very important, and I want full concentration here. Clear? If I draw a line, center of curvature, I'm not drawing the normal every time. Okay, just understood. This is normal. Then it is going like this. Here, one ray is coming like this. It will intersect. Clear? See here, this diagram is very important. How many focus? This is pole, and this surface is polish. Clear? And if you draw any line like this, this diagram is clear now.
Yes, sir.
Okay, I will draw again. Okay, I think it is not clear. I will draw with different color. Little bit clumsy. I will draw big diagram. Okay. Then things will be more clear. This is very important. Don't draw any diagram right now. Just focus here. Okay. going here. Okay, it's coming. This is the principal axis. Clear? This is pole. This is center of curvature. So I will draw some lines. Clear? Very, very carefully. See those lines. Clear?
Yes, sir.
See this very, very carefully. And now I will draw one more. Clear? Now see here, the rays. This is principal axis. Clear? These rays, just see these rays only. These rays are known as paraxial rays. Paraxial PA. Paraxial PR, sorry. Paraxial rays. The rays which are very close to the principal axis. These rays I have drawn very, very far, but these are very, very close. These are known as paraxial rays. While those rays like this, which are far from the principal axis, these are known as marginal rays, MR. MR is marginal rays, while PA is paraxial
Paraxial Rays.
paraxial ray. So marginal rays are those rays far away, the rays which are far away from the principal axis. This is very close to the principal axis. Clear? So I'm writing here far away from the principal axis. So see one important thing. Did you notice, like, why do we consider only paraxial rays? Why? What is the reason? From this diagram, did you notice one thing, like for marginal rays, some are intercepting at this point, some are intercepting where? Here. Did you see this? I have forgot to draw one more, like you can draw. Clear? So for marginal rays, there are different focus. Did you see? But for paraxial ray, all the paraxial rays will meet at a common point. Every paraxial ray will meet at a common point that is known as focus. While some marginal rays meet at this point on the principal axis. Some marginal rays meet at this point, while all the paraxial rays will meet at a common fixed point that is known as focus. We do not want many focus, otherwise there will be the blurredness, means image will not be bright. Clear? If there is more
Yes,
focus, means there is more image. For same object, multiple image will be formed. So there will be defect in the mirror. So on the same principal axis, for example, this is the mirror. This is the mirror. On the same principal axis, marginal rays are intersecting at different points. Parallel marginal rays, some are intersecting at this point, like this. Some marginal rays are intersecting at this point. Clear? Like this. While all the rays, which are very close, like this, to the principal axis, these are intersecting at a common point, like this. All the rays which are very close to the principal axis, they will intersect at a single point. It never change. While the marginal rays, some are intersecting at this point, some are intersecting at this common point, some are intersecting at this common point. So they have different focus. Then what is the reason why they have different focus? Can you tell me?
because the difference of distance between two rays, that is two marginal rays, is great. So the reflection is
No.
also differing.
No. Did you notice like the shape of the mirror? Just check only this
Mm,
surface. This is, check this portion and this portion. This surface is a little bit this aperture because of high aperture. Because of high aperture, this is happening. Because if some rays will coming like this, due to this curved surface, center of curvature, if you draw the normal like this, due to this curved surface, it will go like this. This curved surface, if any ray is coming here, it will go like this. So this curved surface, because of this curved surface, it is happening. See this curved surface. If light rays strike here, it will go here. This curved surface, it will go here. If this surface is less curved, this aperture, because of this high aperture, this is happening. Clear? Is it clear?
yes, sir.
But see the middle portion, this portion only. Here aperture, this aperture, see this aperture. If every ray will come less curved, this surface is very less curved. So any ray strike, it will definitely come here because there is no aperture is very small. This aperture is very small. Clear? That is why I told aperture must be not that much big. It should be small. Clear? So what we will do, either we will do some paint with some black paint. I will paint it the surface. Clear? And then allow only this portion. Or what we can do, we can cut this portion. We can cut this portion. Clear? We can cut this portion and take only this portion, small one, like this. This is the small aperture concave mirror. I will take this only. Then if you take this small aperture, then there will be single focus only. There will be no multiple focus. If I draw any line, parallel rays, if I draw, it will go like this. It will meet always at a common point. Clear? So these rays, this is principal axis. All of these rays are known as paraxial rays. These rays are very, very close to principal axis. Clear? Any doubt?
Yes, sir.
So this
No, sir.
surface, because that is why initially I told the surface must be flat. This is flat surface. It should not be curved. Did you notice this? This is flat.
Yes, sir.
This surface, if this is more flat means not flat, sorry, steeper. I use the wrong term. It should be more steeper. Clear?
Yes, sir.
Like this. It should not be like this. It should be like this. And very, very what? Like this. And it should be having low aperture. So how you will get the low aperture? For example, this is the spherical mirror and this is the center of curvature. So from this mirror you will cut. This is the principal axis. You will cut this much portion. You will cut a very small portion like this. I have drawn like this. It is very small. Clear? And after cutting this portion, you will take it here. So I will take from this bigger sphere, I want small aperture. So I want a small aperture. Then I will cut like this. Then did you notice like this mirror? I will polish this surface. Then I will cut this and take it here. Clear? This is the where I just cut. This mirror is having small aperture. That is why we used to keep our aperture to be small. Clear?
Yes, sir.
Why? To avoid marginal rays. To avoid multiple focus. Clear? So you can
Yes.
write aperture must be small. Aperture, this aperture. Clear? This aperture must be small in order to avoid, see this is the aperture. In order to avoid marginal rays, MR. Clear? Now what is marginal rays? Already I have explained. The rays which are far away from the principal axis. The rays which are closer to principal axis are known as paraxial rays. So in what way I can reduce these marginal rays? Either I will paint the surface. I will paint this surface so that there will be no reflection. I will polish this surface also, this surface also. Then there is no reflection. Clear? Brightness
Yes.
will decrease. I understand little bit brightness will decrease, but the multiple focus problem will decrease. There will be no multiple focus. I can show you this also. Just see here. See this diagram. Is it visible?
Yes, sir.
See this diagram very carefully. This is the lens. Clear? I have drawn, I just take the lens example. Lens, mirror, everywhere. It will be same. This is the axis, optical axis, or we can say principal axis. This is principal axis. And these are the marginal rays. Clear? The rays which are there will be many rays. Clear? This is, I just show you two rays. There will be many marginal rays which are far away from the optic axis or principal axis. This is known as paraxial rays. So see, every paraxial ray is meeting at a common point. This is known as real or focus. Focus of the convex mirror, lens, sorry. While marginal rays are meeting at this point. Did you see? On the principal axis. So there is a difference. There will be two focus. One is one this is, one this is. So if you draw one more marginal ray like this, it will strike here. So marginal rays will strike the principal axis at different points. So there will be different focus. To avoid this, we are making the aperture of the lens or mirror should be small. Clear?
Yes, sir.
Any doubt up to this point?
No doubt, sir.
So whenever I am drawing any formula, not for deriving any formula or writing any derivation, it always be valid for small aperture. Clear? So I'm writing here
Yes.
small aperture. We will understand only for small aperture. Clear? Any doubt?
Yes. No, sir.
This is very important thing like which I just explained. So a small aperture must be, if you want to write, you can write one more. Now write on next topic, focal length. I will give the derivation, okay?
Yes, sir.
Focal length. See how focal length which you learn now, it is not up to the mark. See, if I draw a mirror like this, clear? Just understand this focal length formula which I am deriving, it is valid for concave mirror, whether it is having large aperture, small aperture. Clear? Initially, I will not consider anything else. Clear? Simply my main
Yes.
objective is aperture is, I am taking like, how am I solving? So see, forget like a small, big, everything forget. Filal, till now forget like small, those things I have explained, paraxial, marginal, forget. Clear? I will
Yes, sir.
explain. Now you will see here from infinity. Lines will be coming like this. And this is the center of curvature. You will draw a one normal. And this will go like this. Clear?
Yes, sir.
This is known as focus. Clear? This is known as focus.
Yes.
This angle is theta. This is theta. Then how much this? Tell me. If this is theta, then this is
That will also be theta, sir.
very good because these two lines are parallel and alternate angles are equal. Clear?
Yes.
So see, this is theta, then this is also theta.
Yes, sir.
This point, just write down, this is A, this is B, pole of the mirror, concave mirror. This meeting will be ended. Okay, I will share one more link.
Yes, sir.
So meanwhile, tell me any doubt. See
No doubt, sir.
triangle ACF. I'm drawing here. Here, if this is
Yes, sir.
theta, this is theta. Now tell me, this triangle is known as what? Which triangle is this?
Isosceles.
Very good.
Isosceles.
If what is the property of isosceles? If two angles are equal, and if you draw a perpendicular, clear? A, C, let this is E. If you draw a perpendicular, it will divide the side into equal parts. You know this?
Yes, sir.
If two angles are equal, and if you draw, in case of isosceles triangle, if you draw any perpendicular from any point to that side, then this will be equal. You know this or not?
Yes, sir. I know, sir.
You know this? Now tell me.
Concurrency.
Very good. Congruency rule. This AC is how much? R. Center of curvature to any mirror is the radius of curvature. Clear?
Yes, sir.
Now what is CE? C will be R by 2.
Focal length.
No. Focal length is not. This CE.
Oh, okay, sir.
The C's will be how much? CE is R by 2.
Right.
I want to calculate this focal length. This F. My main objective is to calculate this. Then how to calculate? This is what we will learn. Any doubt?
No, sir.
Now triangle C E F. I think meeting ended. So I am sharing next. If the mirror is of small aperture, then rays will be very important point. If the mirror is of small aperture, then rays will be always be paraxial. No need to see whether rays will be paraxial marginal. If aperture is small, rays will be paraxial rays. Clear?
Yes, sir.
And if this paraxial simply means, what is the meaning of that? Paraxial. If the
They
mirror is
are very close to each other and near the pole.
paraxial means
The rays are close to each other.
very good. Close to not each other, close to principal axis.
Close to the principal axis.
Okay. For paraxial rays, theta is very small. Very small. And you will learn in class 12, if theta is very small, then this sec theta, sorry, if theta is very small, sine theta can be approximately equal to theta, and cos theta is value is approximately 1. So what is the formula then? R minus sec theta is 1 upon cos theta. If cos theta is 1, then sec theta is 1. Then finally, what is the focal length? R by 2. This is what you have learned. R by 2. F is equal to R by 2. Clear?
Yes, sir.
This is the formula most of the teachers teach. This formula is valid for small aperture, and if there is small aperture, there will be paraxial rays. Paraxial rays means the set of incident rays which are closer to principal axis. This is a principal axis. So set means bundle of rays like this, which are closer to principal axis. So if I draw all these rays, these are paraxial rays. After reflection, all will meet at the common point. This common point is known as focus. Clear? Any doubt?
Focus.
This focus is clear or not?
Yes, sir. No doubt, sir.
I think we will
Focus
stop
is
here.
clear.
This focus is very, very important. And I think tomorrow I will explain the numericals. But today, revise this lecture very carefully. Clear? Any doubt?
Yes, sir.
Almost complete.
No
One
doubt, sir.
numerical I want to teach, but today only I will teach because one numerical is left. Now, first of all, I will tell one thing. Small aperture. How do you know like this aperture is small? How do you distinguish? For example, this is the mirror. Clear? See, this ray is coming. Clear? This is the last ray. Clear? So many rays will be here in between that. And this is center. Radius of curvature is 5 centimeter. Clear?
Yes, sir.
This is what? 3 mm. Can you imagine? 3 mm means very, very small like this. And radius of curvature is very high. So check this. As compared to radius of curvature, this 3 mm is very, very small. So I can say this is the case of small aperture. Clear?
Yes, sir.
Can I say this is small aperture? Tell me. I'm drawing here. Principal axis. This is 3 centimeter and radius of curvature is this is 5 centimeter. Can I say?
Not small. Not small.
See, this is 3 centimeter. Radius of curvature is also 3 centimeter. Radius of curvature means from here to here distance.
It is not small, sir.
Yes, very good. Imagine in your mind, radius of curvature simply means if you draw any mirror and take the center from center to any point. This is radius of curvature. 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 So check if this is more. Check this ratio only. R and this distance both are equal or approximately equal, then it is not a small aperture. If y is small, if y is very, very less than r, then we can say this is small aperture. When y is small, then only it will like this, na? Clear?
Yes, yes, sir.
Small aperture means this y must be very, very less than r, like this. Clear?
Yes,
Any
sir.
doubt? Then
No doubt, sir.
y less means like this. Mirror will be like this. Center. This is r, but this is y. Understood? Today's lecture
Yes, sir.
simply means aperture means this opening, and in between here center. See from center, this is radius of curvature. Check. This y is comparable to r, then it is not a small aperture. If this y is very, very less, y is very less means like this. Mirror will be like this.
Small aperture.
Clear? Understood?
Yes, sir. Yes, sir. Understood.
So thank you so much. I will stop the lecture. Tomorrow I will explain how to calculate the focal length. Clear? And
Yes,
these
sir.
lectures, believe me, is very, very important. You will get f is equal to r by 2 everywhere. But you should know the derivation of this, and in which case this formula is not valid. Clear? So if you have any doubt, still I'm asking, just go back to your home, revise the lecture again, check the notes, and if you have any doubt, you can ask tomorrow also.
Yes, sir.
Clear? Today's lecture in doubt?
No doubt,
Clear?
sir. Yes, sir.
Please
Clear, sir.
keep smiling, okay, and work hard like this.
Yes,
Okay,
sir.
these things, small things. Believe me, one day you will realize like these things are how very, very important. I can give one question also, but this time is not allowing me because I have to go for dinner also. Clear?
Yes, sir.
So good night and take rest. I will start the numerical tomorrow and sign convention. Lot of things we will learn. Clear? There's so many
Yes, sir.
things. 1 upon f is equal to 1 upon v plus 1 upon u. I will give the derivation. How this formula came. Everything in detail I will teach you. And once you got all the information, don't worry. If you don't know trigonometry also, I will arrange one session where you will get all the trigonometry, all the graph, sine
Yes,
curve,
sir.
cos curve, everything I will arrange. But in the next month, I will arrange one mathematical session. If theta is small, sine theta is approximately equal to theta. Cos theta is 1. This is this you should remember only. Now only. You will learn these things in class 12. For the time being, you just write this and learn. Clear? Now things are clear. Don't
Yes,
say
sir.
like
Clear, sir.
paraxial rays are very, very close to each other. It means paraxial rays are those rays which are very, very close to principal axis.
Principal axis.
If this is the principal axis, so those rays which are very, very close to principal axis, bundle of rays that is beam, that is known as paraxial. Marginal means those which are very, very far away from the principal axis. And why do you avoid paraxial marginal rays? In order to avoid multiple focus. Because of the curved nature of the mirror, it will reflect at different point. So there will be different focus, and there will be different theta. So I just calculate one derivation, f is equal to r minus r by 2 sec theta. So at the corner, the curved surface which I drawn there, there will be different theta. So there will be different focal length for every marginal rays that we do not want. Clear?
Yes, sir.
Clear now? Okay.
Yes,
Yes, sir.
sir. Clear.
Is still
Thank you,
any
sir.
doubt? Any doubt?
No other doubts, sir. I'll revise, sir. If I have any doubts, I'll ask
Yeah,
tomorrow.
tomorrow please ask. Okay, if you have any doubt, and else we will start the new chapter. Okay. Thank you. Good night.
Thank you, sir. Good night.